The unit circle is a circle centered on the origin of the Cartesian plane. It has many useful applications to trigonometry and radius 1. Today, we're going to go through some useful applications of the unit circle. Here, we've zoomed in on the point AB on the unit circle. This, of course, has distance 1 from the origin, and we'll look at some properties of this point. For one, we can drop a line from AB to the x-axis, and we'll note that the length from here is b. We'll also notice that there's an angle here that we can call theta. Note that one of the core trigonometric functions is sine theta, and if we remember SOHCAHTOA, we remember that sine is equal to opposite over hypotenuse. Now, if we look at our triangle up here that is made from 1, b, and the x-axis, we'll notice that b is our opposite here, and this length 1 is going to be, this radius 1 is going to be our hypotenuse. So then sine theta is going to be equal to b. We also notice that this length here is going to be a. This is because we have up here the coordinate a. Similarly, we have cosine of theta is going to be equal to adjacent over hypotenuse. Of course, adjacent to this angle, theta, is going to be a. So then we have a over, similarly, we have this 1 up here, so then we have a over 1, and a over 1 is equal to a. So then we have this AB is actually equal to cosine theta, sine theta. So in this question, it's asking for the coordinates of x given that the angle here is 30 degrees. It's important to remember that we measure the angle from the x-axis going counterclockwise around the unit circle. So we have 30 degrees. As a reminder, if we drop down this line from x down to the x-axis, we'll have this right-angled triangle. Now, we'll remember here that this length here is going to be corresponding to sine theta. And so since theta is equal to 30 degrees, we have sine of 30 degrees. And as a quick reminder, from our special angles, we know that sine of 30 degrees is half of the hypotenuse, so that's going to be equal to half. Now, we'll also remember that this is going to be cosine of theta. Now, cosine of theta, where theta is equal to 30, if we remember our special angles, is going to be root 3 over 2 of the hypotenuse, right? And this is equal to 1, so then we're going to have that is going to be equal to root 3 over 2. Okay, so then the coordinates of x are cosine of theta, which is root 3 over 2, comma, half.